Hello everyone. Let's simulate the RC low pass filter for our lab. So we'll start with R and then C. I'll bring the voltage source and the ground. Once this is done, F3 is for connecting the wires. I'll do the wiring and the ground. For the voltage, we will just use the AC amplitude because we are going to sweep through different frequencies, so we are not choosing any frequency. We'll just give the amplitude for the AC analysis. For the R, 1K is enough. For the C, since we are going to do the parametric simulation where the parameter C is going to change its values, what I'll do, I'll click the control key in my keyboard and then right click and then curly braces C. So we'll just put the value of the name of the parameter as C within the curly braces so the system will be ready to accept the step command. We call it the step command. Once this is done, we'll take the SPICE directive and we will give the dot step command. So it says dot step param C and we want to simulate it to different frequencies, so we'll list them. So I'll use a list and then 1 nanofarad, 10 nano, 100 nano, 1 microfarad, and 10 microfarad. So this is uh, what the procedure will be. So we'll give the SPICE directive of the parameter through these values. We do the OK. We'll just put it somewhere here. Everything is set. Let's go and run the simulation. For the simulation, we'll choose the AC analysis. The type of sweep, I'll choose as decade. Number of points per decade, 20 points are more than enough. Start frequency will be 1 hertz and the stop frequency will be 1 giga. All right. Okay. Then that's my. Before that, let me use the net label to name it. That's very important. So I'll say V in. V in is here. That will be my V out. So V out. So simulation ran, and then we'll look at the V output, and you see that all the different waveforms and the actually their phases are drawn. So what you'll have to do, you go to the right axis, right click this one, and say don't plot phase. And you will see for the different frequencies, we are getting uh, different diff, sorry, for the different values of the questers, we have the different cutoff values. And the scale here is set as to minus 20 decibel per decade. So what happens in the low pass filter, the single pole low pass filter, the decay is normally 20 decibel per decade. So the system loses its value, its magnitude at the rate of 20 decibel per decade. So these are the decades. And if you can see that within the, for example, 100 kilohertz to 100 megahertz, so 1 megahertz, if you see that normally, if you just look at this magenta line, that the decade starts from here and ends up here. So it's nearly 20 decibel here, minus 80 to minus 100. So it's the system loses 20 decibel per decade of its magnitude. We can change the scale of the decibel scale. We can right click and we can go to logarithmic, or we can right click and go to the linear scale. And the linear scale that gives us like 1 volt, and we can always use cursors to find out the cutoff frequency. For example, I'll right click and to get the cursors. Okay, cursor attached to the green color, and we'll have to see the value of 0 point. So you can keep keep on watching here the magnitude. The moment it's around 707 millivolt, something like here. The cutoff frequency is around 157.4 kilohertz. Now let's go to the active high pass filter. So I'll just close the simulation. I'll close the circuit. No, I don't want that circuit. And I'll open that one. I've already drawn the components and I already set their values. For the operational amplifiers, you'll have to choose from the component list, you have to choose the universal operational amplifier 2. If you choose any other thing, you'll have to either direct it to the library where its functionality is defined or sub-circuit is defined, or you have to use the SPICE directive to define its different parameters. We don't want to do that. We'll just choose the universal operational amplifier, and then we'll start connecting the circuit F3. This one is ground. You guys know that we are going to simulate this circuit. We have the minus and plus power supply and inverting and non-inverting inputs. Non-inverting input is grounded, and this is the high pass filter where the gain will be controlled by these R1 and R2, and the cutoff frequency will be controlled by R1 and C. That's the circuit we're going to simulate. That's what I'll do. Okay, this is the feedback resistance. I'll bring it here. I'll bring a net label and I'll name it V out. I'll just put it here. So for this plus and minus, we have to give it a power supply. So let me bring the voltage. So I'll get one voltage source like this, another one inverted. So V2 and V3. I'll define this one as plus 10 and this one as plus 10. Bring ground F3. And I'll bring my net labels. Net labels say VSS. VDD. So in LT Spice, what we can do if we give two different terminals the same net label, actually they are considered having the same signal. So I'm going to provide the negative power supply over the negative terminal of this operational amplifier and the positive power supply at the positive terminal. So I'm going to use these net labels VSS and VDD, and that will do the job. So I'll bring net label. I'll just call it VSS. Sorry. I'll bring the net label and I'll call it VDD. VDD is here, and then this will be VSS. Now in principle, the VSS will be connected to the positive power supply, which is wrong. It should be VDD, and this should be VSS. So for the voltage source, amplitude of 1, with this current configuration, we'll get the amplification of 100 amplification at the V out. Let's simulate our circuit. AC analysis, we'll go with the decade. Number of points, 20 or more than enough. Start frequency is 1, and then we have, say, 20 kilohertz. Uh, okay, look at the V out. It's clearly high pass filter. And the phase here, again, you can say this, don't plot the phase. So this is my high pass filter. Again, the scale is set to decibels, but I can right click and I'll say, give me the linear. It will give you the 100 volts of the output, which is the gain set by the operational amplifier. That's how you will simulate your circuit. I'll shortly release the lab with both of the circuits, which you'll have to submit. Thank you very much.